Welcome to the Mechanical Engineer. In this video, we are going to discuss the concept of Lamis theorem and we are going to solve a problem on that. So first of all, Lamis theorem states that if three forces acting at a single point are in equilibrium, then each of the force is directly proportional to the sine of the angle between the remaining forces. So we have three forces and we know that the system is under equilibrium condition, which means that reaction is equal to 0. So let us say we have TA, TB, TC and the inclinations are alpha, beta and gamma. So if this system is under equilibrium condition and if the system has only three forces, then as per the Lamis theorem, TA divided by the sine of other two forces. So TA divided by the inclination between TB and TC, sine alpha is equal to TB divided by the sine of other two forces. So TC and TA. When you are considering TA, you have to take the angles between TB and TC. When you are considering TB, you have to take the angles between TC and TB. I mean TC and TA. Sine beta is equal to TC divided by sine gamma, because gamma is the angle between other two forces. Okay, fine. So the problem is an electric light weighing 150 Newton hangs from a point C using two strings as shown in the figure. Find the tension in the strings. So here this electric weight of weight 150 Newton. So the weight of the electric light is given as 150 Newton is hanging from a point C. Okay, so let us name the other 2 points. Let us name it as A and B using two strings. So these two, that is TCB and CA, are strings. So here this system of forces are under equilibrium condition, which means that there will be no reaction force acting and this has only three forces. So we can use Lamis theorem. So before going to the Lamis theorem, as per our previous video, first step we should draw the free body diagram. So first let us draw the free body diagram. I am considering the center point C. So first, starting from the weight, a weight of 150 Newton is acting in the downward direction. Then in between the C and A, we have a string and we know that the string carries only the tension. So a tension of TCA, because from C it is acting to A. TCA is acting like this and we have a tension TCB. So this is the free body diagram. So to use the Lamis theorem, we should know the inclination between all the forces. So here between the wall and the string BC, the inclination is 60 degree. So if I draw a vertical line here, then this angle will also be equal to 60 degree. Okay, fine. So similarly, in between the top surface and the string AC, the angle is 45 degree. So if I draw a horizontal line here, here also the angle will be equal to 45 degree. Okay, fine. So if the angle between AC and the horizontal surface is 45 degree and the remaining angle is 90 degree, so the angle between TCA and 150 Newton is 45 plus 90 degree, that is equal to 135 degree. Okay, in Lamis theorem, calculating the inclination between the forces is very essential. Now, here, in between this vertical line, we know that the inclination of a straight line is 180 degree. So here we have a 60 degree. So the remaining inclination is 180 minus 60. So this is 180 minus 60 and 180 minus 60 degree is equal to 120 degree. So this is the angle between TCB and 150 Newton. Now we know that the overall angle is 360 degree. So we can calculate this inclination by subtracting the other two inclinations from 360 degree. So it is 360 minus 135 minus 120. This will give you the inclination 105 degree. Okay, so in between TC and 150 it is 135, TCB and 150, 120. Between the two strings it is 105. Now let us go into the Lamis theorem. So I'm going to start from the known force 150 divided by the sine of other two forces. That is, if I consider 150 Newton, I have to take the inclination between the other two forces, that is 105 degree. So it is sine 105 is equal to, let us consider one unknown force. So I am starting with TCA divided by the inclination between other two forces is 120. So it is sine 120 degree. Now I can write TCA is equal to 150 divided by sine 105 into sine 120. So if I solve this, I'll get 134.4 Newton. So now I have calculated the tension TCA. Now, with the help of the same known force, that is 150 divided by sine 105, I'm going to calculate the magnitude of the other force. So that is TCB. So when I consider TCB, I should take the inclination between the other two forces, that is 135. So this TCB divided by sine 135. Further, I can write TCB is equal to 150 divided by sine 105 into sine 135. So this will give you 109 Newton. Okay, so like this we can calculate the tension for both the springs. Okay, so as per the Lamis theorem, you should have only three forces and your system should be under equilibrium. And once after calculating the angle between all the forces, you can use the Lamis theorem with the help of a known force and you can find out the remaining two unknown forces. Thank you.